Okay, welcome. Now we're on to chapter 3, 3.1, higher order derivatives, velocity, and acceleration. We're going to look at, this is the first time we're going to be looking at how do you get beyond derivative. What's the first step beyond taking the derivative of a function? To do that, let's take a practical example. S at t is equal to negative 4.9 t squared plus 100. S at t represents the distance or the location of an individual. Let's say somebody jumps from 100 meters in the air and they jump off like a skydiver, jumps out of a plane. The rate at which they're falling, the way that they're falling, their position at any given time in the air is given by negative 4.9 t squared plus 100, where t represents the time since the jump and s represents their position in the air. Are they 100 meters above the ground to start? Then they're at 80 meters above the ground, then 70 meters above the ground, then 50 meters above the ground. That would be this function. If we find the derivative, s prime at t, we would get negative 9.8 t. And then you find the second derivative, meaning if you take the derivative and find the derivative of the derivative, we get negative 9.8. What we want to do is take a look at these and understand what they represent. This one represents the position. S prime at t represents the rate of change of the position, meaning if they're at 70 meters, then they're at 60 meters. What rate are they changing at? Another term for that would be velocity. It's their speed. How fast are they falling? So the derivative of the position function would give you the velocity function, the rate at which they're moving. Now, if you take the second derivative is the derivative of the velocity. So if your velocity is how fast are they coming down, they could be coming down at, 3 meters per second, 10 meters per hour, whatever it might be. But if you look at how fast is their speed changing, now we're moving on to acceleration. And this progression is what we want to look at in 3.1, is to understand what do the higher order derivatives, the first and the second, you can do third derivative and fourth derivative, but for the most part, I think we'll be stopping at the second derivative. What do they give you? Remember, the derivative gives you the rate of change of the preceding function. So s prime at t gives you the derivative of s at t. S double prime at t gives you the derivative of s prime at t. It gives you the second derivative of s at t. So if this is the position, this is the location, this is the distance, the displacement, the derivative of that would be the displacement per time, per hour, which is velocity. And then acceleration is the derivative of velocity. What we're going to do now is we're going to take a few examples just to practice how we would implement this strategy and what we can use or what we can gather from finding the derivative and the second derivative in some examples. So our first question is going to be f at x is equal to x over 1 plus x, and we need to find f double prime of 1, meaning we need to find the second derivative and determine what it would be at x equals 1. So what's your process for finding the derivative? It's very important that you pay attention to what we're doing and how to simplify before jumping ahead to finding derivatives. In this case, we cannot simplify any further, so we're going to go ahead and find the first derivative using the quotient rule. So find the derivative of x, that'd be 1 plus x minus x multiplied by 1 over 1 plus x squared. Okay. Now, technically we could find the second derivative from here, but it makes more sense at this point to simplify all of this down before we jump to finding the derivative. So this will be 1 plus x minus x over 1 plus x squared. So 1 plus x and minus x cancel out, and we're left with 1 over 1 plus x squared. It makes things quite a bit easier. What we want to do now is to find the second derivative. Same idea, 1 over. If you want to, in this case, you can find the derivative using quotient rule, but just for the sake of doing something different, I'm going to rewrite it as 1. I'm going to turn it into product rule. or power of a function rule, I'm going to bring it up and write 1 plus x to the power of negative 2. So if we find the derivative, negative 2 comes down. This is power of a function rule. 1 plus x to the power of negative 3, because I'm going to subtract 1. Multiply it by the derivative of the internal function, which is 1. The answer would be negative 2 over 1 plus x cubed. Finally, I know I'm trying to find the second derivative of 1. So f double prime of 1 would be 2 over 1 plus, and instead of x, I'm writing 1 cubed. 2 divided by, so this is 1 plus 1 is 2, cubed is 8, so it'd be 2 over 8. So my answer here would be 1 over 4. Let's take another example. Pause, I forgot to include the negative. It would be negative 2 over 1 plus 1 cubed, and negative 2 over 8, and then negative 1 over 4. Okay, we're moving on to example 3, number 2, the second question we're looking at. We're given the equation for the position of an object. S at t is equal to 6t squared minus t cubed, and we're starting when t is greater than at 0 and forward. Moving forward, not going back in time. S represents meters, t is in seconds, and we're going to go ahead and answer these questions and try to understand what it is that they're asking us for. So let's do A. Find v, which is velocity, and acceleration at x equals 2. Remembering that s is a position function, so velocity just means find the derivative at x equals 2, then find the acceleration at x equals 2. So what I'm going to do is I'm going to start by finding the derivative function, which is going to be 12t minus 3t squared, and I'm going to find the second derivative function, which is the derivative of this, 12 minus 6t. The question is asking us for at x equals 2 or at time, should be t equals 2. So s prime at 2, this is going to be 12 multiplied by 2 minus 3 squared. So this would be 24. 2 squared is 4 times 3 is 12. 24 minus 12, that will be 2 as well. Same thing here. The second derivative at 2. 12 minus 6 times 2, this will be 0. What does that mean? The derivative function gives you the velocity, which means that at 2 seconds, this function is moving at 12 meters per second. Right? It's going 12 meters per second forward. Not going backward, it's going forward. Double prime, meaning the second derivative, which is the acceleration, at t equals 2 is 0. What this means is it's not accelerating. It's not getting faster. It's not getting slower. At 2 seconds, the speed, the velocity, is constant. It's steady. Let's go to the next one. B. When is the object at rest? And this is another thing we have to understand. If an object is at rest, what does that mean in terms of its position? It means the position does not change. But that's hard to find. What does it mean for the velocity? If an object is at rest and it's not moving, then the velocity is 0. And the acceleration could mean a lot of different things. Acceleration could just mean that it should also be 0. So we'll go with velocity because acceleration can equal 0 even if the object is moving. So let's go find when the object is at rest by taking the velocity function and setting it to 0. Again, why do we do this? Because for an object to be at rest, we know that the velocity has to be 0. So if the velocity function is equal to 0, we're going to do 12t minus 3t squared is equal to 0, and we're going to solve for t. So we can factor out 3t and we're going to get 4t minus, 4 minus t is equal to 0. So we can have 3t is equal to 0, and we can have 4 minus t is equal to 0. So the object is at rest at t equals 0 when it starts, and then at t equals 4. So in the beginning, and then after 4 seconds, the object will be at rest. It's not moving. Looking at C. In which direction is the object moving at t equals 5? Now remember, a reminder that velocity is it's a vector quantity. It has two parts. It has a magnitude and it has a direction. The magnitude would be the speed. It's moving at 12 kilometers per hour. It's moving at 12 meters per second in this case. And it has a direction. This is a positive 12, which means it's going forward. If this was negative 12, it means the magnitude, the speed is 12, and the direction is backwards, or back towards where it began. So let's do C here. We want to know which direction at t equals 5. So we find the second derivative at 5 seconds. So that would be 12 times 5 minus 3 times 5 squared. So 12 times 5 is 60. 5 squared is 25 times 3 is 75. At 5 seconds, the velocity is negative 15 meters per second. The negative implies it's going backwards. We haven't been given a direction. Right? We don't know if it's east or west or north or south, so we ignore that. We just go with it's going in the opposite direction of positive. So we would call that backwards. It's going backwards at 5 seconds. Okay, I'm going to erase this and we'll go on to D. Okay. When is the object moving in a positive direction? So this is not asking for one question. It's not asking for one answer. We want to know all the times when the object is moving in a positive direction. If it's moving in a positive direction, this means that the velocity has to be positive. So what we're looking for is when is the first derivative, sorry, I wrote that wrong. When is the derivative greater than 0? When is the derivative positive? Recall that the derivative of this function is going to be 12t minus 3t squared is greater than 0. Right? We've already done this question when the object is at rest. So we know that the two answers are at t equals 0 and t equals 4 if we were to solve this. What do we do when there's an inequality? We're going to have to make a number line, 0 and 4. Now we want to know before 0 is something that we don't even consider because our function has to be when it's greater than 0. For between 0 and 4 seconds, is it going positive direction or negative direction? And then from 4 onwards, is it going positive or negative direction? We already have the answer because we did this. Find the velocity and the acceleration at time equals 2. At 2 seconds, the velocity was going positive. So we know this is positive. And at 5, it was going negative. So we know this will be negative. But how do we get this if it wasn't if the question did not ask us to do A, B, and C beforehand? So we take a number between 0 and 4 and we plug it into our equation to figure out will it be positive or negative. So we take a number between 0 and 4. Let's plug in 2. If we plug in 2, 12 times 2 is 24. 2 squared is 4 times 3 is 12. 24 minus 12 will be a positive number, so I know the answer is positive. Let's take a number to the right of 4. We can plug in something like 6. Right? If we plug in 6 into this equation, same idea. If we do the calculation, we'll get a negative answer, and so our answer is negative. So if the question is asking when is the object moving in a positive direction, it is moving positive when t is from 0 to 4, but not including 0 or 4. Remember, because at 0 and 4, it's at a rest. There is no positive movement. Finally, E, when does the object return to its initial position? This is a very important question. We're looking for when is the location back to where it started. This is not talking about velocity or acceleration. This question is saying, when is S at t equal to 0? When is the position back to where it started? So to do this, we're going to set the original equation, 6t squared minus t cubed equals 0. We can start by factoring out 6 to factor out t squared. 6 minus t is equal to 0. So we know t equals 0 and t equals 6. So when does it return to its original position? At 6 seconds. Okay. And that would be your final solution, which obviously tells us, going back here, that 6 would not have been an acceptable answer here. 6 would have given us 0. So we would have to plug in a number to the right of 4 to figure out if it's positive or negative. Okay, let's take a look at another example. All right, our next example, example 5 from the textbook. We're given a situation where there are people playing baseball. When the baseball is hit, it follows this function, negative 5t squared plus 30t plus 1. First question is asking, find the maximum height of the ball. To find the maximum height of the ball is the equivalent to finding the vertex in the position function. We know this is a parabola. To find the maximum height, we would just need to find the vertex. To do this using calculus though, right? We can use this using our the old traditional method that we learned in grade 10 and grade 11, which is to find the x value of the vertex, which would be negative b over 2a, and then plugging it in to find the y value. But to do this using calculus, let's look at what we know. The maximum height. What is the ball's trajectory? If it is hit, it goes up and then it comes down. At the maximum height, what do we know? Here, the ball has a velocity that's positive, and then it has a velocity that's negative. The ball is going up, and then it's going down. So we can find the maximum height of the ball by figuring out where is the derivative, or the velocity of the ball, 0. That would be the maximum height of the ball, because at that point, the ball stops, and then it starts to fall. So what do? We're going to find s prime at t, and set it equal to 0. To find the derivative here, we have the derivative, not the original function, will be negative 10t plus 30 is equal to 0. Let's take the negative 30 and divide by negative t, and t would equal to 3. The maximum height occurs after 3 seconds. So to find the maximum height, we're going to do s at 3. We'd have negative 5 times 3 squared plus 30 times 3 plus 1. We have 9 times negative 5 is negative 45 plus 90 plus 1. 90 minus 45 is 45 plus 1 is 46. So the maximum height of the ball is going to be 46 meters. Let's look at the second question. This is the answer for A. Second question is saying to find the velocity of the ball when it is caught 1 meters above the ground. So we want to find the velocity of the ball when it's caught, and it's caught 1 meter above the ground. To find the velocity, we need the velocity equation. We have that right there, perfect. So we know that to answer B, we have S prime at t is going to be negative 10t plus 30. Now to find the velocity, we would need a t value to plug in, which is not given directly. We need to find the time that the ball is caught. The ball is caught 1 meter above the ground. So we need to figure out, in order to plug in the t value, in order to find t, we have to find out when is S at t equal to 1. Okay, so we're going to have negative 5t squared plus 30t plus 1 is equal to 1. When you bring the 1s over, they'll cancel out, and we have negative 5t squared plus 30t is equal to 0. Now we get into our factoring. I can factor out negative 5t, and I'm left with t minus 6, and that will be equal to 0. So the ball is 1 meter above the ground at t equals 0 and t equals 6. Well, if the ball was hit 1 meter above the ground and it was caught after 6 seconds, because we know the ball is not caught at 0 seconds, that's when the ball was hit. So what's the time that we're looking for? 6, so I can just go here. The question that I'm looking for is now S prime at 6, which is the velocity after 6 seconds is going to be negative 10 times 6 plus 30. So negative 60 plus 30 will be negative 30, which turns into negative 30 meters per second, which makes sense because at that point the ball will be coming down. If the ball is coming down, it should be a negative velocity, and the 30 makes sense for its magnitude. So it's important to keep track of what the question is asking for. Are they looking for the velocity, the acceleration, or the actual position of the function? The questions can become a little bit tricky. It does require a lot of practice. Good luck.